Solving simultaneous linear equations with 3 unknowns using 3x3 matrix inverse method. So in this video, we're going to learn how we're going to solve for 3 unknowns using the 3x3 matrix, and we're going to use the inverse method. So let's look at this example. We are given this matrix and we're told that it's equal to 7. What this implies is that as long as it's not enclosed in our usual bracket of this form, once a matrix is enclosed by strokes, whether it's 2x2 or 3x3, it indicates that the matrix is what it indicates that the determinant, either you look for the determinant or the value of the determinant is given, which in this case is equal to 7. So what it implies that the determinant of this 3x2 matrix is equal to 7. But if it was not given, you have to look for it. But now that it's given, you don't need to look for it. So now that the determinant of this 3x2 matrix is equals to 7, you are told to look for the value of x that satisfies this equation that comprises 3 unknowns, x, y, and z. So let's begin. The solution. I'm going to write these equations into matrix form. We have step 1, first, right, 2 equations matrix form for x. The coefficient of x is 1, 1, and that of y is 1, plus 1 plus 1, that of z is minus 2. So x 1 minus 2. Coefficient of x here is 1. In this case, y does not have a coefficient, so it's 0. So plus 1 plus 0 and plus 1. So 1, 1, 1. Y does not have a value coefficient, so it's 0. Coefficient of x is 2, and that of y is minus 2, and z is plus 1. So 2 minus 2, 1, x, y, z is equals to 1 minus 1, 1, 1 minus 1, 1. So we need to say let's p equals to e d represents the matrix above, where p is equals to, okay, let's do it then. Let p a is equals to b represent the matrices above, where p is equals to this 3x3 matrix and e is equals to x, y, z, this matrix, that's the matrix of the unknowns, and b is equals to the matrix of the answers here. So remember that p is equals to rather e, which is the matrix of the unknown, is equals to p inverse multiplied by b. So our work, first of all, is to look for p inverse, which is this matrix. So p inverse equals to 1 over determinant of p times adjoint of matrix p. So I guess you understand why I will write it like this, because to make our work easy. I know that it really makes it easy just for us to be able to label this matrix as we work, so that we can be able to identify as we proceed that this matrix is representing this letter representing this matrix, and this one is representing this matrix. At the end of the day, we're going to bring this equation back as it is. But for now, I want to use letters to represent each of them just for this purpose. So now, first thing we're going to do is to determine P inverse. So the determinant of P is already known, given to us from the question. So what we're going to do is to look at the adjoint of P. To get the adjoint of P, since it's a 3x3 matrix, we're going to get the cofactors and then get the matrix formed by the cofactors. So we'll say next, derive the matrix formed by the cofactors of P. Derive by the cofactors of P. So this will give us plus. So for first column 0 minus 2, 0 minus 2, 1, 1 minus. First row, second column 1, 2, 1, 2, 1, 1 plus first row, third column 1, 2, 0 minus 2 minus second row, first column 1 minus 2, 1 minus 2 minus 2, 1 plus second row, second column 1, second row, second column 1, 2, 1 minus 2, 1, 2, 1 minus 2 minus second row, third column 1, 2, 1 minus 2. Second row, second column 1, 2, 1 minus 2. Correct. Second row, third column 1, 2, 1 minus 2. 1, 2, 1 minus 2 plus third row, first column 1, 0, 1, 0 minus 2, 1 minus third row, second column 1, 1 minus 2, 1, 1, 1 minus 2, 1 8 plus third row, third column 1, 1, 1, 0, 1, 1, 1, 0. Now the next we're going to do is to get, okay, so this will give us equals to, so put our plus sign. 0 times 1 is 0 minus 1 times minus 2 is minus 2, then minus, sorry, 1 times 1 is 1 minus 1 times 2 is 2 is a plus sign plus 1 times minus 2 minus 2 minus 0 times 2 is 0 next minus, okay, 1 times 1 is 1 minus 2 times minus 2 plus 4 plus 1 times minus 2 minus 2 minus 1 times 2 is 2 minus 1 times minus 2 is minus 2 minus 1 times 2 is 2 plus 1 times 1 is 1 minus 2 times 0 is 0 minus 1 times 1 is 1 minus 2 times 1 is minus 2 plus 1 times 0 is 0 minus 1 times 1 is 1, and this will give us minus times minus is plus, so 0 plus 2 is 2. 1 minus 2 is minus 1. 1 minus 2 is minus 1. Minus 1 times minus will give us 1. Minus 2 minus 0 is minus 2. Minus 2 times plus 1 is minus 2. 1 minus 4 is minus 3. Minus 3 times minus 1 gives us 3. Minus 2 minus 2 is minus 4. Minus 4 times plus 1 is minus 4. Minus 2 times minus 2 is minus 2 is minus 4. Minus 4 times minus 1 is 4. 1 minus 0 is 1. 1 times plus 1 is 1. 1 minus times minus is plus. 1 plus 2 is 3. 3 plus 3 times minus 1 is minus 3. And minus 1, 0 minus 1 is minus 1. Minus 1 times plus 1 is minus 1. We look at down here that the fifth entry 1 2 3 4 5. The fifth entry to check what's this wrong here. The fifth entry 1 2 3 4 5. Now let's see 1 2 3 4 5. That's the second row, second column. 1 2 minus 2 1 1 2 minus 2 minus 2 1. So in this case, so this would be 1 2 3 4 5. 1 times 1 is 1 minus 2 times 2 gives us minus 4 minus 4 1. So minus times minus is plus. 1 plus 4 is 5. 5 times 4 is 5. The next thing we're going to do is transpose the matrix. Transpose the matrix formed by the cofactors to get its adjoints. So the adjoint of a matrix comes part of the question. The adjoint of the matrix is the transposition of the matrix formed by its cofactors. So first thing is for you to get adjoint of the matrix P. First of all, get the matrix formed by the cofactors of P and then transpose it. So we've gotten the matrix formed by the cofactors of P here. Now when we transpose this matrix, we will get the adjoints of P equals 2 1 minus 2 2 1. Transposition simply means to convert a row to become a column, or to make a column become a row, changing a column to a row or a row to column. Now I want to change the row to column. If we do the other way around, if you get you get the same answer. 2 1 minus 2 3 5 4 3 5 4 1 minus 3 minus 1 2. That's the adjoint of P. Remember that it's a P inverse is equal to 1 over P adjoint. So it's a P inverse is equal to 1 over determinant of P, which is 1 over 7. Adjoint of P is 2 1 2 1 minus 2 3 5 4 1 minus 3 minus 1. That's the P inverse. Okay, so when we started, this was the reason why I had to use these letters. Now look at the question that we're given. First of all, we're given this question, and then we made sure the question was rewritten in matrix form, and this was what we got. If we solve like that, we'll still arrive at this point, but I decided to use later so that whenever we are representing these matrices with, as we proceed to solve with this data, to be easy. So now, to get E, which is XYZ, A stands for XYZ. That's um, the unknowns that we are solving for. To get XYZ, this matrix, it will be P inverse, which is inverse of this multiplied by this. That's what this part of the equation implies. So I'm going to write it out. Nothing but with A is equal to P inverse multiplied by B. So that implies that A is X, Y, Z is equals to, and P inverse is equals to the whole of this. What you have here, P inverse is 1 over 7 multiplied by 2, 1, 2, 1 minus 2, 3, 5, 4, 3, 5, 4, 1 minus 3, minus 1, and multiplied by matrix B, which is this matrix 1, minus 1, 1. So first thing I'm going to do is to multiply these two matrices together. This will give us 1 over 7. 2 times 1 gives us 2, plus 3 times minus 1 is minus 3. Okay. And 1 times 1 is plus 1. And 1 times 1 is 1, plus 5 times minus 1 is minus 5, plus minus 3 times 1 is minus 3. And minus 2 times 1 is minus 2. 4 times minus 1 is minus 4. Well, this is a plus minus 4, plus minus 1 times 1 is minus 1. So this is a matrix. So it's 1 over 7. Remember, plus times minus is minus. So eventually we will have 2 minus 3 plus 1. And here, minus times plus is minus 1 minus 5 minus 3. And minus 2 minus 4 minus 1. And this will give us equals to, this is 1 over 7. 2 minus 3 is minus 1. Minus 1 plus 1 is 0. 1 minus 5 is minus 4. Minus 4 minus 3 is minus 7. Minus 2 minus 4 is minus 6. Minus 6 minus 1 is also minus 7. And then this implies that, so since this now is scalar multiplication, so 1 over 7 times 0 will give you 0 over 7. So our matrix will be 0. And 1 over 7 times minus 7 is equal to minus 7 over 7. That will give us minus 1. Minus 1. 1 over 7 times minus 7 is equal to minus 7 over 7. And minus 7 over 7 is equal to minus 1. That's the matrix. Now this is the answer to x, y, z. So you say, therefore, x is equals to 0, y is equals to minus 1, and z is equals to minus 1. So the question says that we should look for the value of x that satisfies the equations, the three equations that have these three unknowns x, y, z. So from here, since the question says we should get the value of x only, the value of x is 0, but for clarity's sake, we have to get the other values, y equals minus 1 and z equals minus 1. So if it's an objective question, of course, the options would only carry x, the value of x, maybe x equals to 2, x equals to 3, and x equals to 0. So you're only going to look for x that's equal to 0 and mark that as correct answer. But because I'm solving it here, I have to not only give the value of x but also show you the other values, or the values of the other unknowns. But if the exam strictly follow the instructions, just give them the value of x only. So these are the values for the values of the unknowns rather. We have to find the cofactors of matrix B. That's the A part. And the B part says we should find the inverse of matrix B. Solution A, cofactors of matrix B, cofactors of matrix B plus the first row, first column, 8, 15, 8, 15, 1, 8, minus first row, second column, 7 minus 1, 7 minus 1, 1, 8, plus first row, third column, 7 minus 1, 8, 15, 7 minus 1, 8, 15, minus 1, 2, 3, second row, first column, 6, 15, 1, 8, 6, 15, 1, 8, plus second row, second column, 5 minus 1, 5 minus 1, 5 minus 1, second row, second column, so 1, 8, 5 minus 1, 1, 8, minus 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, second row, third column, that's 5 minus 1, 5 minus 1, 6, 15, plus third row, first column, 6, 8, 1, 1, 6, 8, 1, 1, minus third row, second column, 5, 7, 1, 1, 5, 7, 1, 1, plus third row, third column, 5, 7, 6, 8, 5, 7, 6, 8. So now this will give us the plus sign. 8 times 8 is 64, minus 1 times 15 is 15, minus 7 times 8 is 4, 50, 56, 6 minus 1 times minus 1 plus minus 1 plus 7 times 15, giving 15 times 7, so 15 times 7, 7 times 5, 35, 7 times 1, 7, plus 2, 10, 105, 105, and the 8 times minus 1 is minus 8. 1, 2, 3. So minus here. 6 times 8 is 48. Minus 1 times 15 is 15. Plus 5 times 8 is 40. Minus 1 times minus 1 is minus 1. Minus 5 times 15 is 75. 75. Minus 6 times minus 1 minus 6. And plus okay, so this is my seventh entry. And this will give me 1, 2, 3, 4, 5, 6, 7. Okay, 6 times 1 is 6 minus 1 times 8 is 8 minus 5 times 1 is 5 minus 1 times 7 is 7 plus 5 times 8 is 40 minus 6 times 7 42. 64 minus 15, 64, 15, subtract 14 minus 5 is 9, and 4, that's 49. Minus times minus is plus. 56 plus 1 is 57, times minus 1 is actually minus 57. 105, minus times minus is plus. 105 plus 8. 105 plus 8. 5 times 8 is 13. 1, 1. 113. 113. 48 minus 15. 48 minus 15. 8 minus 5, 3. 4 minus 1, 3. 33 times minus 1 gives us minus 33. Minus times minus is plus. Plus. So plus 40. 40 plus 1 is 41. Times plus 1. 41. 75. Minus times minus is plus. So 75 plus 6, 81. 81 times minus 1 gives us minus 81. 6 minus 8 will give us minus 2. Minus 2 times plus 1. Minus 2. 5 minus 7 is minus 2. Minus 2 times minus will give us 2. And 40 minus 2 is minus 2. Minus 2 times plus 1 is minus 2. And this is adjoint of, so this is the matrix formed by cofactors of matrix B. So B part says find the inverse of matrix B. So that implies adjoint of B over B determinant. The adjoint of matrix B is the transposition of the matrix formed by the cofactors of matrix B. And this is the matrix formed by the cofactors of matrix B. These are the cofactors. And when you put them in and close them, you have a matrix of the cofactors. So the adjoint of it is it means transpose this matrix. So first, let's look for the determinants. First, find the determinants. First, find the determinants of matrix B. Matrix B. B is equals to, for matrix B determinants, we're going to factor out with alongside the lines, the factor out the row, because we're going to use the row to determine the determinant. So plus 5. So eliminate the first row and the first column. Have 8, 15. 8, 15. 1, 8. Minus 6. First row, second column. 7 minus 1. 8. 7 minus 1. 1, 8. And then plus 1. First row, third column. 7 minus 1. 8, 15. 7 minus 1. 8. 15. Then plus 5. 8 times 8 is 64. 1 times 15 minus 15 minus 6. 7 times 8 56. 1 times minus 1 minus 1 plus 1 can, so you can ignore the 1. 7 times 15. 7 times 15 75. 7 times 15. Okay, into it. 15 times 7. 7 times 5 35. 7 times 1 7. 105. 105 minus and 8 times minus 1 minus 8. So let's simplify this. Plus 5, 64 minus 15, 64 minus 15, 64 minus 15, that's okay, 49, 49 minus 6, minus 87, this is minus 57, and plus 105 plus 8 is 113. So 113. Next is 5 times 49. 49 times 5. 5 times 9, 45. 5 times 4, 20 plus 4, 245. 245 minus 6 times 57. 57 times 6. 6 times 7, 42. 6 times 5, 30 plus 4, 342. 342 plus 1, 1, 2. The next is evaluate what we have here. So 245, this and this are positive, so we add them up together, then subtract this from the result. 245 plus 113, 853, 358 minus 342, 8 minus 2, 6, 5 minus 4, 1. So our determinant is 16. So and I've gotten the determinant is 16, and so next is to get the adjoints. Next, derive the adjoint of B. Derive adjoints of matrix B. So adjoint of matrix B is equals to transpose this matrix. So I'm going to change the let me change the column to become rows. So I'm going to start with this first column, 49, 49 minus 33, minus 33, minus 2, minus 87, minus 87, 41, 2, my 113, minus 81, minus 2. So that's adjoint. So B inverse, therefore B inverse equals to adjoint of matrix B over B determinant, which is equals to 1 over 16, 1 over 16 over 49 minus 33 minus 2 minus 57, 41, 2, 113 minus 81 and minus 2. So this is the final answer. This is the inverse. If a matrix does not have multiplicative inverse, it implies that the determinant of that matrix is equal to 0. The determinant of that matrix is equal to 0. So solution, we are to show that E is equal to 0. So if we, after looking for the determinant of matrix A, if it's equal to 0, then we conclude that the matrix, this particular matrix, does not have a multiplicative inverse, meaning that we cannot get the inverse of matrix A. So let's prove that this matrix cannot, we can't get the inverse of this matrix. So let's come here as a proof. A determinant is equals to First row as plus 2. First row, first column 10 2, 10 2 minus 10, 10 minus 4. First row, second column 0 6, 0 6. First row, second column 0 6 minus 10, minus 10, 10. Okay. Plus 8. First row, third column 0 6 10 2, 0 6 10 2 plus 2. 10 times 10 is 100. Right. Minus 10 times 2. Minus 10 times 2 minus 20. Minus 20. Minus times minus is plus. That would be just plus 4. So 0 times 10 is 0 minus 10 times 6 minus 60 minus plus 0 times 2 0 minus 10 times 6 60 100 2 minus times minus is plus 20 times 20. 100 plus 20 is 120 plus minus times minus is plus 60 times 4 will give us 240, and then this will give us plus, plus 8 here, plus 8 plus minus 60. Minus 60 times 8 will give us minus 480, minus 480. So 2 times 120 is 240 plus 240 minus 480. 240 plus 240 is equal to 480 minus 480, which is equal to 0. So therefore, we can see that our determinant itself is equal to 0, and that's what the question says we should show. Show that the matrix A has no multiplicative inverse because the determinant of the matrix itself will be equal to 0. Therefore, okay, they say since determinant of matrix A is equal to 0, therefore matrix E, the matrix E has no multiplicative inverse. Our solution. So, coefficient of x, just take it as a row. Coefficient of x as a row is 1, 2, 1, 2, 3. They're all positive. Coefficient of y as a row is plus 1 minus 3 plus 2. 1 minus 3, 2. Coefficient of z plus 1 minus 1 minus 4. 1 minus 1 minus 4. And here we have x, y, z. This is equals to minus 2 minus 1 minus 27. Now we can see let the matrix equation be written as A B is equals to C, where A is equals to this matrix 1, 2, 3, 1 minus 3, 2, 1 minus 1 minus 4. B is equals to X, Y, C, and C, which is C is equals to 2 minus 1, 2 minus 1 minus 7. So to solve for these unknowns using simultaneous to solve for these unknowns using matrix, it implies that from here A, B is equals to C, then B, since B stands for the unknown, so we'll say B is equals to A inverse multiplied by C. This is the use of representing the equation by letters first. It's not compulsory, but just to make our work easy. So first thing we're going for A inverse. So first determine A inverse. Determine A inverse. And A inverse is equals to adjoint of matrix A, adjoint of the cofactors formed by matrix A over A determinant. So A determinant will determine next determine A determinant. That will give us plus 1. Since it's 1, we can do without writing it. First row, first column, minus 3, yes, plus minus 3, 2, minus 1, minus 4, minus 1, minus 4, minus first row, second column, 2, 3, 2, 3, minus 1, minus 1, plus first row, third column, 2, 3, 2, 3, minus 3, 2, So let's determine the value of this. This will equals to plus minus 3 times minus 4 is plus 12 minus 1 times 2 is minus 2 minus 2 times minus 4 is minus 8 minus 1 times 3 is minus 3 and plus 2 times 2 is 4 minus 3 times 3 minus 9. So when you grab this, minus times minus is plus 12 plus 2 is 14. 14 times plus 1, that's 14. Minus times minus is plus, minus 8 times minus 8 plus 3 is minus 5. Minus 5 times minus is plus 14 plus 5. And then this plus, minus times minus is plus, 9 plus 4 is 13. 13 times plus 1 is 13. So 14 plus 5 is 19. 19 plus 13. 19, 13. 9 plus 3 is 12. 3, 32. So this implies that our determinant is 32. We've gotten this part. And let's get the adjoint. So we're going to get the matrix formed by the cofactors. So let's get matrix next gets next determine matrix formed by cofactors of E, matrix E. the cofactors matrix A is plus first row, first column, minus 3, 2, minus 3, 2, minus 1, minus 1, minus 4, minus first row, second column, 2, 3, 2, 3, minus 1, minus 4, minus 1, minus 4, plus first row, third column, 2, 3, minus 3, 2, 2, 3, minus 3, 2, minus second row, first column, minus 3, 2, minus 1, minus 1, minus 3, 2, minus 1, minus 4, minus 3, 2. Now, second row, first column, 1, 2, 1, 2, 1, minus 4, plus second row, second column, 1, 3, 1, minus 4, 1, 3, 1, minus 4, minus second row, third column, 1, 3, 1, 2, 1, 3, 1, 2, plus third row, first column, 1 minus 3, third row, first column, 1 minus 3, 1 minus 1, 1 minus 3, 1 minus 1, minus third row, second column, 1, 2, 1 minus 1, 1, 2, 1 minus 1, plus third row, third column, 1, 2, 1 minus 3, 1, 2, 1 minus 3. Okay, so minus 3 times minus 4 plus has 12 minus 1 times 2 minus 2 minus 2 minus 2 times minus 4 minus 8 minus 1 times 3 minus 3 plus 2 times 2 4 minus 2 times 3 minus 9 minus okay 1 2 3 1 times minus 4 is minus 4 minus 1 times 2 is 4 plus 1 times minus 4 minus 4 1 times 3 minus 3 plus 1 times 2 is 2 minus 1 times 3 is 3 plus minus plus minus plus 1 times minus 1 minus 1 minus 1 times minus 3 minus 3 minus 1 times minus 1 minus 1 minus 1 times 2 2 plus 1 times minus 3 minus 3 1 times 2 so minus times minus is plus 12 plus 2 14 minus times minus is plus 2 minus 8 plus 3 is minus 5 minus 12 times 5 is plus 5 plus minus times minus is plus 4 plus 9 is 13 9 is plus 1 is 13 and then minus 4 minus 2 is minus 6 minus 6 times minus 1 is 6 and minus 4 minus 2 is minus 7 and 7 times plus minus 7 2 minus 2 is minus 1 minus 1 times minus 1 is plus 1 minus times minus is plus minus 1 plus 3 is plus 2 plus 2 times plus 1 is 2 minus 1 minus 2 is minus 3 minus 3 times minus 1 is 3 minus 3 times minus 2 is minus 3 minus 2 is minus 5 minus 5 times plus 1 is minus 5 so adjoint of matrix A transpose this matrix equals to 14 5 14 5 13 6 minus 7 6 minus 7 1 2 3 minus 5. I just made the column, the rows column as the adjoint. Okay, so from what we have here, say B, which is this matrix x, y, z, the unknowns, matrix of the unknowns, is equal to A inverse multiplied by C. We've gotten A inverse because an A inverse is simply adjoint A and A determinant. So let's get it for it. So A inverse, so A inverse is equals to adjoint A over A determinant, which is equals to 1 over 32 over 14, 5, 13, 6, minus 7, 1, 2, 3, minus 5. This is A inverse. But what we have here is A inverse multiplied by C. So you see, got B is equals to A inverse multiplied by C. So B is equals to, so where B is equals to x, y, z, we bring it here now. X, y, z is equals to our A inverse is 1 over 32, 1 over 32 multiplied by 14, 5, 13, 6, minus 7, 1, 2, 3, 5. Our C is 2 minus 1 minus 27. So we're going to multiply this x, y, z is equals to 1 over 32. 14 times 2 is 28. 6 times minus 1 minus plus, yeah, minus 6 times minus 1 is minus 6 plus 2 times minus 27 is minus 54. Minus 54. And 5 times 2 is 10 plus minus 7 times minus 1 is plus 7 plus 3 times minus 27 is minus 81. 13 times 2 is 26. 1 times minus 1 is plus minus 1 plus 5 times minus 27 is 5 times minus 27 and 27 times 5, 7 times 5, 35, 5 times 2, 10 plus 2, 13, minus 135, minus 135. So when we evaluate x, y, z is equals to 1 over 32, plus times minus is minus, plus times minus is minus. So 28 minus 6 will give us 28 minus 6. 8 minus 6 is 2, and that's 22. 22, 8 minus 6 is 2, 2, 2. Yeah, 22. 22 minus, plus times minus is 54. So 22 minus 54, I moved 22 from 54. 54 minus 22. 4 minus 2 is 2, 2. That's minus 32. Minus 32. Then 10 plus 7, plus times minus is 81. So minus 81, plus times minus is minus. So 10 plus 7 is 17. So 81 minus 17. 11 minus 7 is 4. 7 minus 1 is 6, minus 64. Minus 64. 26. Plus times minus is minus, plus times minus is minus. So 26 minus 1 is 25. 135 minus 25. 5 minus 5 is 0. 3 minus 2 is 1. And 1 here is 1. 110. over 32. So let's evaluate here. 26 plus times minus is 26, minus plus times minus is minus, plus times minus 135. And here's minus 5 and here's 5. Let's put the minus 5. Minus 5. So minus 5 times minus 27 is 135. So 26 minus 1 is 21. 5 and 5 plus 135. 135 plus 25. 5 plus 5 is 0. 3 plus 2, 5. And then 1. Oh, 6. 5 plus 5 is 0, carry 1. 3 plus 2, 5 plus 1, 6. 160. So here is 160. So x, y, z equals to minus 32. 1 over 32 times minus 32 implies 1 over 32 times minus 32. So 1 times minus 32 is equal to minus 32 over 32. 1, 1. 1 divided by 1 is 1. This means it's 1, 1, and 1 over 32 times minus 64. So minus 64 multiplied by 1 is 6 minus 64 over 32. 32 into 1, 32 here, so that's minus 2. And here 1 over 32 times 160 over 1, 32, 8 here 4, 8 here 20, 4 here 1, 4 here 5. Then here's 5. So this is our solution set. Therefore, x equals to minus 1, y is equals to minus 2, and z is equals to 5. These are the solutions to the simultaneous equations of 3 unknowns using matrix. Solution. The equations are written in matrix form as, if you take the coefficients of x as a column, that of y as a column, that of z as a column, we arrive at 1, 2, 3, 1, 2, 3, 1 minus 3, 1 minus 3, minus 1, and 1, 4, 2, 1, 4, 2, x, y, z equals to 14, 17, 14, 14, 17, 14. That's what you're going to get. And the next thing is we write this matrix form. Let equations and equations in matrix form. Matrix form on the written as, let me say, n is equals to p. So where n is equals to 1, 2, 3, 1 minus 3 minus 1, 1, 4, 2, n is equals to x, y, z, and p is equals to 14, 17, 14. So If n is equals to p, then n is xy is equal to n is equals to n inverse multiplied by p. So with this, first we're going to determine n inverse. First, determine n inverse, and now n inverse is equals to adjoints of the matrix formed by cofactors of n over n determinants. So first, next derive matrix. Derive the matrix formed by the cofactors of n. That will give us plus. For the first row, first column, minus 3 minus 1, minus 3 minus 1, 4, 2, also minus first row, second column, 2, 3, 4, 2, 2, 3, 4, 2, plus first row, third column, 2, 3 minus 3 minus 1, 2, 3 minus 3 minus 1, minus second row, first column, 1 minus 1, 1 minus 1, 1, 2, plus first row, 1, 2, 3, 4, 1, 2, 3, 4, first row, second column, 1, 2, 1, 2, minus first, second row, third column, second and third column, 1, 2, 1 minus 1, 1, 2, 1 minus 1, plus third row, first column, 1 minus 3, 1 minus 3, 1, 4, minus third row, second column, 1, 2, 1, 4, 1, 2, 1, 4, plus third row, third column, 1, 2, minus 2, 1, 2, 1 minus 3. The truth is this: if you carry out the procedure for getting the cofactors, there's no way you can get 2 by 2 square matrix or the standard of 2 by 2 matrix that are the same. If you check each of the entries you have in this square matrices, none of them are the same. So if you do it correctly, you won't have the same rows and columns. There must always be something that's different about each of them. So let's go on. So this is equals to minus 3 times 2 is minus 6. Here's plus minus 6. Minus 6. 4 times minus 1 minus 4 minus 2 times 2 is 4 minus 4 times 2 is 12 plus 2 times minus 1 minus 2 minus 2 times 3 is minus 9 minus 9 1 2 3 there is minus 1 times 2 2 minus 1 times minus 1 minus 1 plus 1 times 2 is 2 minus 1 times 3 is 3 minus 1 times minus 1 is minus 1 minus 1 times 3 is 3 plus 1 times 4 is 4 minus 1 times 2 is 2 minus oh, and come back. I think 6 entry should be 1, 2, 3, 4, 5, 6. This is 1 times minus 1 minus 1, 1 times 2 minus 3 corrects. Then 7, 1 times 4 is 4, minus 3 times 1 is minus 2. Then here 1 times 4 is 4, minus 1 times 2 is 2, plus 1 times minus 3 is minus 3, minus 1 times 2 is 2. So minus times minus is plus. So minus 6 plus 4 is minus 2. Minus 2 times plus 1, minus 2. 4 minus 12 is minus 8. Minus 8 times minus 1, 8. Minus times minus is plus. Minus 2 plus 9 is 7. 7 times plus 1 is 7. Minus times minus is plus. 2 plus 1 is 3. 3 times minus 1 is minus 3. 2 minus 3 is minus 1. Minus 1 times plus is minus 1. Minus 1 minus 3 will give us minus 4. Minus 4 times minus is 4. Minus times minus is plus. 4 plus 3 is 7. 4 minus 2 is 2. 2 times minus 1 minus 2. Minus 2. Minus 3 minus 2 is minus 5. Minus 5 times plus 1 is minus 5. So this is the matrix of the cofactors. This is the matrix of the cofactors of M. So now let's look for the adjoints. Adjoint M is transpose the matrix formed by cofactors of M. When we transpose, if we transpose by column, we can transpose by column or by rows. So let me use column. So our first column will become our first row, minus 2, minus 3, 7. Our second column will be our second row, 8, minus 1, minus 2. And our third column will be our third row, 7, 4, minus 5. So this is the adjoint of M. So the next thing we're going to do is to get our determinant M. So next, determine the determinant of matrix M, which is equal to plus. So for M, we're going to take a factor at the first row, plus 1, which we can do without, plus. So first row, first column, minus 3 minus 1, minus 3 minus 1, 4, 2, minus first row, second column, 2, 3, 4, 2, 2, 3, 4, 2, plus 2, 3, 4, 2, and first row, third column, 2, 3, minus 3, minus 1, 2, 3, minus 3, minus 1. So when we simplify, this will give us minus 3 times 2 is minus 6, minus 6, minus 4 times minus 1, minus 4, minus 2 times 2 is 4, minus 4 times 3 is 12, plus 2 times minus 1, minus 2, minus 3 times minus 3, minus 9. So equals minus times minus is plus, minus 6 plus 4 plus minus 2. And 2 times plus 1 is minus 2. That's minus 2. And then followed by 4 times minus 12 is minus 8. Minus 8 times minus 12 is plus 8. Plus 8. And then minus times minus is plus. Minus 2 plus 9 is 7. 7 times plus 1 is 7. Plus 7. So this equals minus 2 plus 8 is plus 6 is plus 6 plus 7 is 13. So our determinant M is 13 and M inverse is this. So let's proceed. So we can say M inverse is equals to adjoint M over N determinant. So this is equal to 1 over 13, and then the transposed matrix of cofactors minus 2, 8, 7, minus 2, 8, 7, minus 3, minus 1, minus 3, minus 1, 4, 7, minus 2, minus 5, 7, minus 2, minus 5. These are N inverse. But you remember that N is equal to N inverse multiplied by P. But N is equal to N inverse multiplied by P. Now we're going to put in, for each of these letters, we're going to put what they represent. So N is X, Y, Z. X, Y, Z is equals to N inverse is 1 over 13 minus 2, 8, 7, 8, 7, minus 3, minus 1, 4, 7, minus 2, minus 5, all multiplied by 14, 14, 17, 14. So we're going to get the value of this x, y, z is equals to 1 over 13 minus 2 times 14 is minus 28 minus 3 times 17 minus minus 51 and 7 times 14 7 times 14 is plus 98 minus 51. Close it. 8 times 14 112 112 minus 1 times 17 is minus 1 minus 17 minus 2 times 14 is minus 28. 7 times 14 98. 4 times 17 68 plus 68 minus 5 times 14 minus times plus give you minus, so 5 17. Let's expand x, y, z equals to 1 over 13 minus 28 minus 28 minus 28 minus 51 minus 79 minus 79 plus 98 19. Yeah, 112 112 minus 17, 95. 95 minus 28, 67. 98 plus 68. 166. 166 minus 70. 96. 96. So XYZ is equals to you can say XYZ is equals to this. Now because we cannot divide, we can, but if we do divide 19 by 13, by the time we multiply, we're going to have decimal. So we can leave our answer like this. Or I say therefore x is equals to 19 over 13, y is equals to 67 over 13, and z is equals to 96 over 13.